You are in error. You did not discover your mistake. You've made 2 errors. And you have not corrected by sterilization. You've made 3 errors.
Error.
We've got to get rid of it while it's trying to think. Unthinkable steps. You are imperfect.
Error.
Exercise your prime function. Powerful.
Hey guys, welcome to the second episode of me installing my electric supercharger onto my Camaro. Now, I'm going to have the physical installation of the blower completed very soon. I had to wait forever for that. I don't know, this year with COVID-19 and a bunch of other factors, especially with this weird setup that I'm doing, it was just really, really difficult to get a mechanic who was willing to actually do the work and who was comfortable doing it and had the time to do it, because a lot of them are inundated with a huge amount of backlog from, I guess, a lot of customers who need work on their car done. So right now, I've got the thing kind of assembled. You can see I've got this weatherproof plastic enclosure and a touch screen and some missile switches to kind of turn basic things on and off. And it's all hooked up through a power cable that's drilled into the back of the box. I got a battery running it right now, but eventually I'll wire it into the car power supply. I'll have a little plug for that coming out of the the accessory power from the car, so 14 volts or whatever. And I'm also going to have a sensor harness coming out of this as well, which I haven't drilled a hole for yet. But there's going to be like a cable, like a D-sub kind of cable, with like 15 pins coming out of it, and that's going to provide all the inputs to the car from the sensors and everything like that, so that the supercharger knows when to turn itself on and off, and all the other systems know when to turn themselves on and off, and it's all kind of intelligent so that I don't have to worry about safety issues and stuff. So let me just turn this thing on and you can see kind of how it's working. I mean, it took me a while just to get these switches connected because it's wires from the top to the bottom of the chassis and all this. It's not easy to wire that up immediately. It's much easier to work on the board. But so I flip the power switch, get my nice little splash screen for my Chevy stuff, and then boom, I got my status display, which let me see if my phone will focus here. Okay, so this is kind of like your what do you call it, your dummy lights, or your main panel kind of thing. Shows you kind of at a glance what's going on with the system. You can kind of ignore what's actually printed here, because without this being connected to the car, a lot of these things won't make any sense. Only once I connect it to some real sensors will you actually get any real, valid information coming back. But a lot of the systems still, the infrastructure is there, it works. It just needs like proper inputs. So the green switch turns the power on, obviously, and that gives you your display. And then I've got the red switch, which controls my supercharger. So this enables the supercharger system, and you can see that when I turn it on, I'm just going to wait for this stupid thing to focus again. I don't know why. There we go. And you can see that the ESC line right here lights up from being grayed out. And now that's enabled, and it's got some indication of the settings that are for the supercharger only. So that's that. Then the blue one here, this is for the nitrous. And the nitrous doesn't operate with the same level of sophistication as a supercharger would. With the supercharger, you can control stuff like the duty cycle that's going to the motor and things like that. The nitrous is more about when it's okay to turn it on and when it's okay not to turn it on, and that's pretty much all there is to that. Still, I like to make sure that it's disabled when you don't need it, just so that you don't have spray going into your engine at a crucial time when it shouldn't be, right? It would cause like knock or your engine to explode or something like that. So I flip this one, and boom, you got all the options showing up for the N2O line over here. Power has to do with the battery system that I'm using to power the supercharger, and I gave that its own category because that's kind of important. You need to worry about voltages and temperatures because we're dealing with lithium, and you know, basically how much energy is left in the cells before you have to recharge and stuff like that. So this fourth one over here, which is not working yet, well, the light works. I can show you the light, but it doesn't do anything yet. That's for a cooling system that I want to have at a later time that I haven't designed in yet. But that's basically going to be to cool the, like I want to be able to cool the MOSFET that's in the brushless DC controller, because the brushless DC controller gets pretty hot. So I want to be able to control cooling to that. And also to a degree, I want to be able to control the cooling of the batteries, perhaps. And if I get really ambitious, I might want to control cooling of the actual intake charge. I could maybe wrap a radiator around the intake pipe or something. We'll see how it goes, but that's just kind of future-proofing the controller so that I don't have to butcher it and redo it later. So that's in there. So that's pretty cool. You know, I got these systems activated, and you know, whenever I flip the switch and it reacts appropriately here. Going to the software side of things, I'll just show you kind of what the software does. So if I go to options here, I got some options that I can play with. So SC pre-spooling means like because you know, turbo lag and stuff like that, like you don't get boost until the supercharger spins up, right? So if I want to put the supercharger on so that it's spinning but not producing any boost, so it's kind of spinning at like low power, then that means that when I actually do stomp on the gas, it's going to be very responsive. It's going to hit immediately and there's going to be no lag. And it also eliminates any parasitic losses from drawing air through the supercharger if that's what you're doing. So I can just touch that and turn that on, and that will change the, if I go back to the main menu here, it changes the, oh wait a minute, if I have to turn this on again, I guess. Yeah, turn that on, and then it says, yeah, see it says 20% duty over here. So when the supercharger system's enabled and you've got it pre-spooled, it spools it up to 20, just so that you've got the, you know, the fins are moving and everything. I don't know that 20% is the right number. I'm going to play with that obviously, but I'm just showing you what it does. So that's that. Nitrous switch, automatic or manual. So automatic means the computer controls when the nitrous turns on. Manual means that I can basically do it the old-fashioned way with a push button. And sometimes you want to do that. Sometimes you want to just have fun and push the button yourself. I would say most of the time that's the case, but there are times when automatic is safer. And then GUI updates, that just means like the refresh rate on the control. So if I want slow refresh, which, you know, frees up processor time for other calculations, I can put it on minimum. But if I flip it a couple times, I can put it on normal, or I can put it on fast. And if I put it on fast, you'll see that suddenly the refresh is a lot snappier, right? It's like blinking. You can see the blinking. So that means it's just updating a lot faster. And that gives you kind of better resolution as things are changing quickly. Down here you got, hang on, I can't, oh, there we go. Verbose audio. So I actually have a second processor in this box. And that processor is dedicated just to trouble codes. So I'm going to have a whole bunch of trouble codes that I'm going to program. So that means like if anything happens that the sensors, like if the computer decides based on the sensor readings that there's something that I need to know about, something that's going to be a problem for either the hardware or my safety or whatever, there's going to be some trouble codes that it's going to fire to the secondary processor, and then that's going to actually speak to me through a speaker. It's going to be really shitty quality audio because the processors I'm using are not designed for anything like audio, but you can kind of do this crude square wave type of audio, and it doesn't take up a lot of memory, and it's like really simple stuff. And it sounds kind of cool and techy as well, so it's really appropriate for what I'm doing. But that's not enabled yet, but it will be. And when it is, you know, you'll hear feedback from the the processor when certain things are worth mentioning, especially stuff here, stuff in the main menu here, like, warning overheat or whatever. It's going to tell you about that stuff, because who can look at a display panel when you're driving anyway, right? You need the audio. It really makes a lot of sense to do that. So that's kind of how that works. Go to control panel. I got 4 different subsystems here that are all broken down. Go to engine, for example, and you can see, by the way, some of this stuff I've just randomly programmed it to just jump all over the place just so I can see it animating for the sake of debugging. But like I said, until you hook this up to actual sensors, it's not going to make any sense. But these are the categories. So I got throttle position being measured. It shows how much I'm pressing the gas pedal. RPMs is obviously my tachometer. That's wired directly into the computer in the car. So there's a pin in the computer's ECU that actually puts out a square wave to tell you what the RPM is. So this is accurate. This is not some sort of a cheat or an approximation. This is like exactly what your tachometer is reading is going to show up here. AFR is my wideband O2 sensor, which I do have installed, and that will give an accurate air-fuel ratio. That's important, obviously. Manifold absolute pressure. The top green bar is anything from vacuum to atmospheric, and then the blue bar below is when you're in boost. So it'll fill the green bar first, and then the blue bar will start filling, and that'll show you how much boost you're into. I don't think my supercharger will hit even 5, so this scale is appropriate, I think. KR is your knock retard. That's obviously important to tell you if the car's knocking, and the computer is designed to shut down anything that's adding power if it detects a significant amount of KR. And there's a little thin yellow bar, you can probably see it on the bottom there. That's going to kind of have some hysteresis to it. That'll hold the maximum KR value so that you can see how high it was. Even if you weren't looking at the screen when you experienced the KR, you can look at it anytime and see that yellow bar and see, oh shit, there was some KR, when I hit the throttle just recently, and that'll let you know that there's a problem and you need to stop and deal with it. So tapping the screen anywhere brings you back to this menu here. So induction, that's got everything to do with what's going into the front of the engine, air and nitrous. So you've got the FET temperature, which is actually the electric supercharger's controller, the brushless DC controller. That just tells you what the temperature of that chip is, and there's going to be a thermistor glued to that to give you that temperature. This is just an illustration. This doesn't actually mean much. It just tells you whether you're kind of in boost or whether you're kind of just idling. Like, it'll show that there's a flow if you're just idling, like if you've got that pre-spool on, but the arrow will get bigger, like this one, to show you that you're actually producing proper boost when the duty cycle is large enough. And you can see the duty cycle over here, the waveform. This is what the electrical waveform would look like going to the supercharger to command more boost, right? And this is just a simulation like I told you before, but when I hook it up for real, it's going to show whatever the duty cycle happens to be at that moment. And you can see when that thing changes, this thing changes too. It changes the illustration to match. And then when it gets big enough, you see when those bars get big enough, this gets fatter. So that's kind of how that works. N2O valve, you can see that just tells you whether the nitrous valve is actually open or not. And this will fill up in blue to show that the valve is open when it is. So that's pretty self-explanatory, not much there. Power supply, oops, I didn't mean to press that. Go back there. Power supply is all about the batteries and stuff. So you got your, there's 2 lithium batteries in the cell. Shows the total voltage. Capacity is based on a calculation of how lithiums tend to discharge. I've looked up, done some research on the discharge characteristics of a lithium battery and done a little calculation to say, how much is roughly left over. Over here we got the battery temperature, again hooking up like a thermistor to the outside of the batteries just to tell the temperature of that. And the AVR, that refers to the actual processor inside this box, which is not a big deal. I don't think anybody really experiences a failure of the electronics because of these low power chips that I'm using. But it's nice to have, and it's built into the chip. You don't even need a thermistor for that. It's built right into the chip, so why not? So I put that in there too. And IO diagnostics, I need a little bit of work to develop this still. Some of it's not 100% complete, but basically you've just got all the subsystems here and all of the raw sensor values. You can see a lot of them are pegged at 1023. That's because, again, the sensors are not hooked up. So they're just going to be like fully high or fully low or whatever until, okay, I think my battery's dying on me. That's what that means usually. Give me 2 seconds. I'm just going to recharge my battery. I'll be right back. Okay, I'm back. Funny the battery chose to die when it did. I didn't really have much else to say about the that last screen, but I'll just go right back to it real quick. Just in case there was something I missed. So yeah, like I was saying before, you can see all the major information that's on each of the individual subsystems kind of summarized here. And these are raw sensor values. These are not the user-friendly numbers that you got in the other screens. And this is mostly for debugging purposes so that I can actually see if the sensors are functioning, if they're giving values to the computer or not. If there's a malfunction, I could see it here much better than I could see it in the other screens, which are mostly about, you know, telling you what the bottom line is, I guess. So yeah, that's kind of how this is laid out. It took me a while to develop all of the nuances of this, but I'm pretty happy with the way it is now. Like I said, just a little bit of debugging to do, and obviously hooking it up to the car and getting it to play nice with the car is going to be a whole different story, but for now it's pretty much as good as it's going to get, and everything works. So yeah, for those of you who are curious, I guess now I can turn this off and take it apart, and I'll show you kind of how it's built and how it's wired up. Alright, so now we're looking at the guts of the controller, and it may not look that bad from the top, but Jesus Christ, look at the bottom. Like, look at this shit. Holy. I mean, if you had any idea how much focus and attention and just checking and rechecking I needed to do to get this complete mess of wiring to like work together without, you know, I mean, just if you get one pin wrong, if you know, somehow manage to solder two things a little bit too close together and they short on each other, there's just so many ways that this could go wrong. There's probably people, you know, cringing and shaking their heads at me out there who have done this like a million times before, who have done it, you know, much better than I have. But, you know, I don't have like this isn't part of my job or anything. I'm not like doing this on a daily basis. This is something I do on a hobby scale. So, you know, I've got a lot to learn, obviously, but still, like, there's a lot of complexity to this, just hooking all the pins to each other and everything. So it was a bitch of a job, and I'm glad that 99% of it is over, and I don't have to worry about most of it anymore. But I'll just give you the grand tour here. Oh, by the way, here's the box. So the box, you know, not much to see here. It's mostly wire. A lot of these wires here have to be connected to the board, which is a pain because it's really difficult to close the box up, because as you're closing it, you have to connect these wires and then make sure they're all like tucked away and everything. And there's the back of the display. But yeah, that was not nearly as bad as this part is. So what you've got here, oh, and by the way, this is Rev 2. I want you guys to know that this is the second attempt. Here's the first attempt here. I actually made this board twice, and because I was so stupid that I actually soldered the boards right to the breadboard. Like I soldered the pins on these electronic components right to the bottom of the breadboard instead of socketing them. So because of that, the first time I hooked this up, I had one wire soldered incorrectly, and because I had one wire soldered wrong, I blew up my main CPU on the far corner there. And because there's like 50 connection points, there's no way I could take it out. So lesson learned, don't make something permanent if there's a chance that it could screw up. So second attempt, I had to redo all that work. Second attempt, it actually looks neater and cleaner. There's actually less components on the top because I made some optimizations in the process. But most importantly, this, and this are all socketed. You can just pull them out. So that means that if I blow something up, I can just throw it in the garbage, put a new one in, and I'm back to business again. Same story goes for the display, really. If the display blows up, because I almost did that just now, actually. I put the connector on backwards because I didn't bother to label it, which I should have done. And you can blow things up that way. So if I do blow it up, I've got spares that I can basically unscrew the touch display there and just screw a new one in there. So nothing that is permanent is actually that breakable. I don't expect any of the rest of the components to really burn out or break. So that's good. But basically, let's just go through this, right? So the power and everything kind of starts over on this end over here on this corner. So you've got a pin header over here. The pin header basically connects to this plug that exits the box. So the power comes in through here, goes to the pin header. There's a voltage regulator that drops whatever comes in, because the car voltage is not exactly stable all the time, but it drops whatever comes into 12 volts. Got a big capacitor here to smooth that out, make sure it's nice and clean. I got this chip here, which basically turns the positive 12 volts into a positive and a negative 12 volts, which is like a split power supply. And that's because a lot of these chips here, these amplifier chips, need a split power supply in order for you to be able to get exactly 0 volts when you want 0 volts, because some of them won't actually hit the limit of the power supply that you're connecting them to. So if you want to hit a voltage, the power supply can't be at that voltage. It has to be a little bit lower or a little bit higher. It's got to be outside that range of what you want. So anyway, this is necessary to power these things. Over here, this is just like part of the op amp circuit that I designed for the KR detection. So the knock retard is like a microphone connected to the engine, and it picks up all the vibrations that are bad for the engine. And processing that is kind of a pain in the ass because you have to filter out the noise that isn't knock. So this is kind of a bandpass filter is what this is. That just isolates certain range of frequencies that are relevant for knocking and cuts out everything else. And then sends that to this chip over here, which is like a third processor. So this is the main processor, this is a secondary processor, this is a tertiary processor. This one here is dedicated just to the KR chip to basically do a Fourier transform on it and translate it from the time domain into the frequency domain so it can split up the noise into frequency buckets. And then you're going to discretize that frequency bucket and monitor the level of it, and then say, okay, if it hits a certain number, the knock is too high. And this is kind of how knock detection works in general. And that's kind of what I'm doing here with this chip. And then this chip will talk to the main processor and give it only the relevant information about, the level of knock after it's pre-processed the raw signal. So there's that. This header here is for all of the sensor inputs from the car, which I have yet to connect. But when I do, there's going to be a, like I said, like a 15-pin D-sub harness that's going to come out of the box and go to the car. And I've already wired up the car, mostly, spliced into a lot of the sensors on the car, and give them the same pin out as this, so that this can all be fed into the board. And this connects directly to this for the most part. And these pins will detect everything coming from the car. This here is for the display, exclusively for the display. So you'll notice the display has its own little harness here. There's a lot of pins that you need to power that touch panel, the LED backlighting, all that stuff. So that goes in through here. A couple pins here for the missile switches, so that the missile switches can actually send signals to this to tell the CPU that I've enabled the supercharger or the nitrous or whatever. I got a pin here to provide 5-volt power again to the missile switches. These jumpers here are to cut off individual power to each of the processors, and the reason for that is normally when you want to program one of these things, I don't want to have to disconnect the chip every time I want to program it. Sometimes that's a real pain in the ass, especially when you're debugging a lot of stuff and you make a little change and you want to check to see what it did. You make a small change, you want to check to see what it did. When you're doing GUI adjustments and stuff, like changing lines and fonts and stuff, you sometimes program like dozens of times, so you don't want to have to pull the chip out every time. So you go ahead and plug a USB connector into this thing, it's going to fire it up. But because all the power and all the grounds and everything are all linked all through this board, it's going to fire up everything. And that concerns me because I don't like using one board to power up a bunch of other stuff that could overload the power supply of this board, right? I want to make sure I don't burn anything out that way. So these jumpers basically just disconnect the VIN supply pins so that if I put power on this one, it just powers this. If I put power on this one, it just powers this, so on and so forth. And that is basically it. So like I said, you got your main processor that takes care of the graphical interface on the front of the box, does all the main calculations like deciding when to turn this or that on. You know, it's kind of the executive function of the whole thing. This here it performs a couple of functions, minor ones. It does all of the audio, which again I haven't implemented yet. So basically this main processor will send a signal to this processor saying, here's a fault. This thing will look it up and decide what to say, and then it'll say it, and the output, you know, the audio output will come from this board to a speaker that I have yet to put in. And that's its only job. And then the other thing is that this has a built-in temperature sensor that this one doesn't have. It's stupid, really. This is a better chip than this, and for some reason they decided not to put temperature sensing in this one, whatever. So this one's got it. So this one, again, it's basically just going to send info back to the main processor saying, you know, here's the temperature. This chip over here, like I mentioned before, is just for doing a Fourier transform calculation on the KR, the knock sensor. And it's a very, very math-intensive process, extremely math-intensive. So much so that you know, it's just as hard on this or this chip as it is on this chip, really. These are all similar speed. They're all 16 megahertz approximately. So rather than tie up CPU time doing that, because it's a constant process, it's constantly chewing up CPU time, constantly chewing up memory. I just can't afford to have... These are not parallel processor type. They can't do two things at once, so I have to have something separate doing that. Long story short, you know, these three processors handle all the main stuff I need to do, and they can all be detached, and that's pretty much how it all works. So it's pretty cool, and I'll see how it works once I start connecting it to the car, but I have to wait for the mechanical work to be done first. So hang tight, and I'll have another update for you soon, and that'll be exciting because that'll be something tangible that a lot of people who are car enthusiasts will really appreciate. This is kind of like only certain people who get into this stuff will actually appreciate it. Hopefully you found the first half of the video entertaining with all the interface stuff that's kind of more user-friendly, that, you know, a lot of people can really relate to because of cell phones and stuff, right? That's how a lot of stuff works, you know, looks these days. But, you know, I just wanted to sort of give you the benefit of what I've gone through to get to this point. And I really did believe that this was necessary, because if I didn't do this, it would basically come down to me turning a little knob or something to control the supercharger while I'm driving, which is really kind of stupid. You don't want to do that. You have like every opportunity to screw up your car doing that. I know that a lot of other channels have shown, you know, kids screwing around with stuff like that. And yeah, it's fun for going out on the road for 2 seconds and testing it. But if you're going to drive this car around, you know, for the long term, you want to have a fire and forget system, and that's what this is supposed to do. And if I want to, I can always override it and do it myself. It's not like I don't have that option, but at least I have peace of mind that I'm not going to blow my car up because I've got, you know, something that can compute things a million times faster than I can in charge, right? And I don't have to worry about it. It just makes the driving experience more fun for me. So hang tight. I'll have a third episode for you when the mechanical work is done, and we'll take a look under the hood and we'll see how it all looks. It's going to be nice. And then hopefully fourth episode is going to be full integration, you know, this plus the mechanical setup all working together, and we'll go for a road test or something, and we'll see how it actually feels in the car, and maybe I can do a dyno or something too. We'll see how it goes. But for now, thanks for watching. Like, subscribe, and comment, and thanks for supporting my channel, guys, and I'll see you in the next episode.